All right, welcome to the review for our test on powers, roots, and radicals. The videos are going to be in 15-minute increments. I'm going to do my best to explain them as clearly as possible, so sit back and enjoy. One thing you might want to have out is your cheat sheet. That's what I'm going to be using to get the regular numbers, the coefficients, out of the radicals. Otherwise, as far as exponents go, remember we'll be using division. All right, so starting with number one, on 1 through 4, the idea is to use these without the calculator, and I can't recognize what 64 to the 4/3 power is in my head, so what I'm going to do is rewrite it as a radical. And if you remember, the denominator is the root number and the numerator is the exponent number. So I will be starting with taking 64, the cubed root of 64, and then taking that number to the 4th power. So the cubed root of 64 is 4. And then 4 to the 4th power is 256. And we are not going to worry about pluses or minuses on this. So just whatever the calculator would say. Number 2, same idea. I will be taking the cubed root of 125, which is 5. And then I'm going to take that 5 to the 4th power. And when I'm done, I get 625. Number 3, the only thing that's going to change is because of the negative exponent, it's going to move into a denominator. So then I'll be taking the cubed root of 64, which is just 4, so my final answer is 1/4. And then number 4, the 1/2 is just going to distribute to everything, so basically it becomes 1 to the 1/2 and 36 to the 1/2, and remember 1/2 is the same as the square root, so I'll just end up with 1/6. So there's 1 through 4, pretty basic. On the next set of problems, you're going to see a lot of numbers that have perfect roots, but again, I want to take out as much as possible, and I might have to rationalize. There aren't too many that we're going to have to rationalize on the front, and taking a quick scan, I don't see any that we're going to have to rationalize on the front. So my goal is just to get out as much as possible. So number 5, both of these have a perfect square root. 81 turns into 9. And remember, for the exponents, we divide, and 2 goes into 4 2 times. So there's number 5. Same thing with number 6. Square root of 121 is 11. And 2 divides into 10 5 times. No remainder, so perfect square roots. All right, let's move up to the top. All of these have perfect fifth roots. So the fifth root of 243 is 3. And again, I'm going to divide with my exponents. So 5 goes into 5 one time. And then 5 goes into the 15 3 times. So there's my final answer for 7. Now on number 8, only the x to the 6 has a perfect cubed root. So what I'm going to do is break down the negative 250 into factors. And again, I want to take out as much as possible. So I'm going to be taking out a negative 125 as opposed to a 125. So the negative 125 can come out, becomes a negative 5. The 2 will stay in there. So when I start building up my answer, this is what will be staying in there. So a 2 will stay in there. The x to the 6 has a perfect square root, so that can all come out. And as far as the y, 3 goes into 5 one time. And then I'm still going to have a remainder of 2. So there's my final answer for number 8. Number 9, as far as perfect roots go, negative 32 can come out. That becomes negative 2. X to the 6, some of it can come out. 5 goes into 6 one time. But then I'm still going to have a little bit left over. So when I start my leftover piece, I will have an X left over in there. And then 5 can go into 7 one time. And then I would have a remainder of 2. And there's number 9. All right, let's move along to number 10. Again, not everything is perfect. I'm going to first break down the 200 into 102. So the 100 can come out and become 10. The 2 is going to stay in there. As far as the exponents, 2 goes into 6 3 times, so that all can come out, and 2 can go into 7 also 3 times. But then I'm going to have a b to the first power left over. There's number 10. Let's go to number 11. On number 11, let's see. What I'm going to go ahead and do is I know that the x squared has a perfect square root, but I'm going to go ahead and put everything in one square root first. So I get x to the 5th y, and z to the fifth. And now I'm just going to take out as much as I can. There are definitely other ways to go through this problem. So 2 goes into 5 2 times, but again, I'm going to have a leftover of 1. The y will not come out at all. And then same with the z, 2 goes into 5 2 times, but I'm going to have a leftover z. So there's number 11. Number 12. On number 12, again, I'm going to combine the radicals first. But as I combine them, I'm going to break down the 16 into its factors. So 16 is going to break down into 8 and 2. There's my x to the 7th. I'm sorry, I'm going to go ahead and combine the x's. So I'm going to make it x to the 8th. And then I'm going to combine my y's and make it y to the 7th. And then there's the 6 that's there. I'm not forgetting about it. So when I look at what's perfect, the 8's going to come out and become a 2. As far as what's left over in there, still inside a cube root, is going to be 12 from the 2 times 6. My x3 goes into 8 2 times, but then I'm going to have 2 left over as a remainder. And then 3 is going to go into 7, also 2 times. I'm going to squish this in there, and then I just have 1 left over. So there's my final answer, and just so we can tell, I'm going to put the root in parentheses because it is a cubed root and not y to the 23rd power. All right, the bell's going to ring. Hold on. All right, let's go to number 13. The first thing I notice on 13 is the y to the 16th. If I simplify, I have no need to rationalize. So 4 goes into the 16 4 times, no remainders. And then 4 goes into 5 once, so one of the x's could come out, but I'm still going to have an x left over in there. And this is the final answer for 13. So there's the first page, went pretty quickly. All right, going to the next page. I'm dealing with exponents a lot on this page, so I'm going to be following the rules of exponents. Because I just want to assess on the rules of exponents, if you end up with an x or an exponent in the denominator, I'm not going to worry about that rule, even though it's technically a rational or radical in the denominator. We're not going to go through rationalizing it. So the first thing I'm going to do on 14 is take the 3 and distribute it, to the 1/6 and also to the 1/12. So when I do that, I get 363 to the 1/2 power, and then 9 to the 1/4 power. 363 I will go ahead and recognize as a square root because that's easier, I think, for some of us to see that we can simplify it. And I can turn 363 into 121 and 3. So the 121 will come out and will become an 11 along with the square root of 3. And then as far as the bottom goes, I'm just going to leave it as 9 to the 1/4. I do not need for you to rationalize it because we are going with the rules of exponents here. Okay? All right, let's go to number 15. So on 15, the exponent of 3 is first going to distribute to the 2. So in that step, I have 2x to the 11/6 over x to the 4/3. And then all of that is to the 6th power. And now I'm going to take that 6th power and distribute it to everything in the parentheses. To the 2, to the 11/6, which just becomes x to the 11th because the 6's will cancel out. And then to the x to the 4/3 on the bottom, which becomes 24 over 3, which is the same as x to the 8th. My x's here are going to simplify into x to the 3rd. And then 2 to the 6th power is going to become 64. So here is my final answer for number 15. All right, number 16, following the rules of exponents, because the bases are the same and the exponents are negative, I'm actually just going to flip the exponents around. And then because the bases are the same, I can subtract the exponents, and 4/3 minus 1/3 is 3/3, which is the same as the first power, so my answer is just 27. All right, let's move to 17. So on 17, I'm going to distribute the exponents. So just focusing on the exponents here, 2/3 times 3/4 is 6/12. So I'm going to get 6 to the 6/12 power, which is 6 to the 1/2 power. And 1/2 is a square root, but 6 does not have a perfect square root, nor does it have factor. So I'll just leave it like that. Number 18, since the bases are the same, I'm going to be adding these exponents. 1/3 and 4/3 is just 5/3. And I'm just going to leave it like that. Number 19, the 1/3 is going to distribute to each thing in here. It multiplies in. So it's going to become 54 to the 1/3 and 64 to the 1/3. And remember, 1/2, 1/4, 1/3, these are all simple roots. So I'm going to rewrite it like that. Because then I think you guys will see this better. That 64 to the 1/3, that the cubed root of 64 is 4. And as far as the 54 goes, what I'm going to do is break that down into 27 and 2. And then the 27 can come out as a cubed root and become 3. And then the 2 would stay inside that cubed root. So this is the final answer for number 19. All right, I'm going to scroll back up to the top and we're going to take a look at 20. On 20, so these actually both have perfect cubed roots. 27 becomes 3, 64 becomes 4, and when I'm done, my final answer is 12. On 21, because there's exponents and radicals, I'm going to rewrite it all as radicals. So I'm going to change it 6 to the 1/2 and 6 to the 1/3, and then have all of that be to the 6th power. So this 6 is going to distribute in, and I get 6 cubed. And then it's going to distribute into the 1/3 and get 6 squared. And when I'm done, I'll have 6 to the 5th power, which is worth 7,776. And notice, you guys, I'm not going straight to the answer. I know you can type this into your calculator, but I'm assessing, can you get to the answer with a small amount of help from your calculator. All right, adding, subtracting. Adding and subtracting is the pickiest of all. I can't add and subtract things with exponents or radicals unless they're perfectly alike. So I'm going to work to get these perfectly alike. So first on 22, I'm going to take the 1/10 and distribute it in. So x to the 8/10 and y to the 4/10. And then I'm going to simplify these fractions into x to the 4/5 and y to the 2/5. And now moving on to the 3, I'm going to distribute the 4 into 1/5 and into 4/10. So here is the 3 just going along. So 4/5, and this becomes y to the 4/10. And I'm going to simplify this up a little bit. The 4/10 can become 2/5 again. So when I look, I have a 3 of these x to the 4/5, y to the 2/5, and I'm just going to put a 1 in there for the sake of adding. And so when I'm done there, let me move this down a little bit, my final answer is that I have 4 of these x to the 4/5 and y to the 2/5. And that's my final answer for 22. All right, 23. What I'm going to do on 23 is I'm going to add these up first. So 2 plus 7 on top is 9 with a 5th root of, I'm sorry, not a 5th root, but 9, and then in the square root, 9 to the 5th power. And then on the bottom, I have the square root of 9 to the 7th power. So what I'm going to do is build this up. And so what I'm going to do here is I'm actually just going to focus on the exponents here. So when I do that, I'm going to build this up with another square root. And I need at least 9 exponents right here, and I have 7. So I'm just going to add 2 more on. And then that gives me in the denominator the square root of 9 to the 9th. And you know what, I'm already realizing I'm doing this problem wrong, and I'm about out of time, so what I'm going to do is erase this, and I'm actually going to put problem 23 in the next video segment. So if you want to pick up 23, catch the next one. All right?